We're looking at a second example of a medication that is dosed based on the patient's body surface area. In this problem, I'm telling you that it's based on body surface area, but when you're doing homework, you may not know. So our key to knowing if we should use body surface area is to look how the medication is ordered. And so we have an order for this patient to receive 20 milligrams per meter squared. So the meter squared is the label of body surface area, and that is our clue to use body surface area. We're given the patient's weight in pounds and their height in feet and inches. So I'm going to be using the formula that uses the pounds and inches. You need to memorize this formula. So the formula is the pounds times the inches divided by 3131. I'll need to convert the 5 feet 5 inches to inches. So there are 12 inches in a foot, so I can multiply this by 12, so that equals 60. And then I'll add in the 5 inches for their height, so we have a total of 65 inches for our patient. Next, I'll go to my calculator and I'll use the formula in my calculator. So in my calculator, the first thing I'll do is type the square root button. Then I'll type 173 times 65 divided by 3131. Then I can end parentheses if I want to, and finally hit equals. When I do that math, I come up with an answer of 1.90, and that's rounded off. We normally round to the hundredth place, but meter squared is a metric measurement, so we're not going to include that trailing zero. So I have the patient's BSA as 1.9 meters squared. Next, I want to figure out exactly how much this patient should receive. So I looked at the order, which is based on their body surface area, and I want to change that order into an order that has a label just milligrams, so that I know not a rate, but an amount. So I'm going to multiply times 1.9 meters squared over 1, and that 1's just a placeholder, or I can think of that as my one patient. And doing this math, I come up with an order of 38 milligrams as the amount this patient should receive. That doesn't finish the question, though, because we're asked how many milliliters. My next step is to convert the milligrams to milliliters. In order to do that, I have to know how strong my medication is. So looking at the third bullet point, the label says 50 milligram vial, reconstituted with 50 mLs of sterile water for injection, as defined by the United States Pharma Encyclopedia. And then this is really important. Each ml of the resulting solution will contain 1 milligram. So that is how strong my medication is. I'm going to use that with dimensional analysis. So I'm going to multiply by put 1 milligram on the bottom per 1 ml on the top. If it makes you more comfortable, I can put this over 1. Milligrams then cancels, and I calculate that the volume for this would be 38 milliliters. This very last step, I use dimensional analysis. You could use the nursing formula here. So if you wanted to, you can work with desired over half times quantity. Once I cancel the meters squared, I have my desired amount, which is 38 milligrams. What I have on hand is 1 milligram in a quantity of 1 milliliter. And so you can see in the nursing formula, milligrams cancels, and I get the exact same answer as I did with the dimensional analysis, that we would like to give the patient 38 milliliters.